All right, ladies and gentlemen, here we are in the third of 5 videos over transversal proofs. Again, this video is going to show 2 additional proof examples. Once again, I want to stress that the solutions shown here are not by any means the only way to do these proofs. They are simply one solution. So this is just one approach. Okay, there are actually many different correct proofs for each of these proof solutions for each of these proofs. So we're going to do 3 videos here to cover the second set of proof notes. There'll be 2 proofs in each video. In here we're going to prove several, or one, or at least one, we're going to prove one really important geometry theorem so that later on when we get to it in the book we won't need to prove it because we will have already done it. All right, so these first 2 proofs are pretty basic. That's why I'm putting all this information on the front of the video, because that'll eat up some of the time. These are both pretty simple, pretty basic, pretty standard transversal proofs that are going to be on this video. So here we go. Once again, anytime we do a proof, we always start with the given. The given is that that line M is parallel to line N. That is our given. Now, if M is parallel to N, that means that all of our theorems and postulates apply. However, we can't go directly to our solution because angle 2 and angle 5 in this picture do not have a vocabulary-based relationship. They're not consecutive interior, they're not consecutive exterior, alternate exterior, they're not corresponding. There's no vocab word that describes them, therefore we do not have a theorem or postulate that describes their relationship. So instead, what we need to do is come up with a relationship, a third angle that is related to both angle 2 and angle 5. In theory, that third angle will be congruent to one of our 2 angles, one of these 2, either angle 2 or angle 5, and it'll be supplementary to the other. It does not matter what angle we use to do this. So for instance, I'm looking at angle 1. And again, angle 1 is not the only angle you could choose to do this. You could pick almost any angle in that picture and you could work it out in the same number of steps. So let's say we look at angle 1. Angle 1 and angle 5 are corresponding angles. So angle 1 is congruent to angle 5 by the corresponding angle postulate. Because if M and N are parallel, which is what the given tells us, then each pair of corresponding angles, like angle 1 and angle 5, must be congruent. Okay? The other relationship, that's how 1 is related to 5. We then have to ask ourselves, well, how is 1 related to 2? Well, angle 1 and angle 2 form a linear pair. And our supplement theorem tells us that angle 1 plus angle 2 therefore must be 180 degrees, because that is what the supplement theorem says. It says that all linear pairs add up to 180 degrees. Now notice that we've stated that angle 1 and angle 5 are congruent, and we've stated that angle 1 and angle 2 add up to 180 degrees. We're trying to show that angle 2 plus angle 5 is 180 degrees. So actually, in reality, we should probably write angle 2 first in that sum. So we should write measure of angle 2 plus the measure of angle 1 equals 180. It doesn't matter what order we write them in, really, but to be as exact as possible, we want angle 2 to come first in our example. So in that statement there, that equation on step 3, if angle 1 was not there, if it was replaced with angle 5, then we would have what we want. Right now, we don't have anything in our proof that states that angle 1 is equal to angle 5. We do, however, have a statement that says angle 1 is congruent to angle 5. So we use a very common geometry trick. If angle 1 and angle 5 are congruent, that means that their measures are equal, because that is what angle congruence means. That is the definition of the word congruent in that statement, is that those 2 angles, angle 1 and angle 5, must have the same measure. That's what makes them congruent. So now that we've done that, what we can do is we can take the measure of angle 5 and we can substitute it in for the measure of angle 1 in our earlier equation, giving us that the measure of angle 2 plus the measure of angle 5 equals 180 degrees, which is what we were asked to prove using the substitution property. We substitute measure of angle 5 into step 3 for the measure of angle 1, which generates what we're trying to prove. That does it. That is a pretty standard proof. Now that's not, again, not by any means the only way to do that proof. There are lots of other ways you could have done it that would have been correct. If you want me to check one for you, I'm happy to do that. Just bring me a solution and I'll tell you whether or not you're correct. Okay, so here's another proof. We're going to do one more on this video and then we'll stop it and we'll start a fourth video and then one more video after that. Again, 2 proofs per video. So here's the second proof for this video. Once again, we start with the givens. Line B is parallel to line C. Angle 9 is congruent to angle 5. Those are the givens for this particular problem. Now, because B and C are parallel, that allows us to use our rules, our corresponding angle postulate, and all of the theorems based on our other vocab words along lines M and N. What I mean is we can relate these 4 angles, 5, 6, 7, and 8, to these 4 angles, 13, 14, 15, and 16. We can relate 1, 2, 3, and 4 to 9, 10, 11, and 12. We are not, however, allowed to relate these 4 to these 4, or these 4 to these. We have to use the fact that B and C are parallel, meaning that M could be a transversal or N could be a transversal. So let's be a little bit careful here. Now, angle 9 and angle 5 do not, repeat, do not have a relationship. However, there are 2 different angles up here, 1, 2, 3, and 4, that are related to both angle 9 and angle 5. So what we're going to do is we're going to pick one of those 2 angles. I look at this and I immediately have angle 1 jump out at me. I immediately notice that angle 1 and angle 9 are corresponding angles, indicating that 1 is congruent to 9 because, again, B and C are parallel. So these sets of angles and these sets of angles are vocabulary word rules apply. So we can state that angle 1 is congruent to angle 9 using the corresponding angle postulate. Now once we do that, our algebra brain should kick in and go, wait, I've got 2 different congruent statements. Angle 1 is congruent to angle 9, angle 9 is congruent to angle 5. We should immediately know that if 1 is congruent to 9 and 9 is congruent to 5, then 1 has to be congruent to angle 5 by the transitive property. And folks, if angle 1 is congruent to angle 5, that proves that line M is parallel to line N by the converse of the corresponding angle postulate. Because if a pair of corresponding angles, 1 and 5, are congruent, that means the lines they lie on, N and M, must be parallel by the converse of the corresponding angle postulate. That does it for this proof. It also does it for this video. Again, this is not the only solution. There are other solutions. I'm happy to check any solution you come up with. But this is one solution being used as an example. Okay? So our next video will cover 2 additional proofs, including a very important geometry proof that is a little bit tricky, and then one pretty standard proof. And then the last video will cover 1 standard proof and 1 very much algebraic-based proof. Thank you very much for your time and attention. Again, there's still 2 more videos worth of examples you can use. Thank you for your time.